Alright guys, let's do number 57. Alright. A car is parked in a steep incline overlooking the ocean where the incline makes an angle of 37 degrees below the horizontal. So if it's below the horizontal, that means that this incline right here is going to be 37.0 degrees. And you have a car that's parked right here, and it's gonna and it's on neutral, and the negligent driver leaves the car in neutral, and the parking, so it's on neutral, the parking brakes are defective, starting from rest at t equals 0. So let's just start this at t equals 0 right here. So, and this travels, and this is going to accelerate at 4 meters per second. So the car rolls down the incline with a constant acceleration of that, traveling at for the whole 50 meters. So this whole thing is going to be 50 meters. So this is going to accelerate at 4 meters per second square. All right. So after it travels 50 meters, after it falls the edge, the cliff is 30 meters above the ocean. So it's gonna basically go into a free fall motion here. And then it's going to go, whoop, it's going to go slide down towards the ground, whatever that component is. All right, it's actually not going to look like that. So it's going to like carry that component, and it's going to fall down. Anyway, whatever. All right, let's answer for part A. So for part A, the speed of the car when it reaches the edge of the cliff. Well, we can do that, right, folks? If that's the acceleration, if that's 50 meters. Let's find the time it takes for it to reach 50 meters. So that's 50 meters equals, if it's going to start from rest, that's going to be 4 meters per second squared divided by 2 times t squared. Let's find the time. So that's 50 meters times 2 divided by 4 meters per second squared. Square root the thing. And there we go. There's the time. We're going to find that time, and we're going to plug it into this other equation to find the speed. And that speed is really just going to be, whatever that 4 meters per second square times that time it takes. All right, so let's plot that. So that's going to be the square root of 2 times 50 divided by 4. Square root the thing, 5 seconds. Oh, that's a nice number. So the time it takes for it to reach is going to be exactly 5 seconds. 5 times 4 is going to be 20 meters per second. So that speed for part A is going to be, the speed is going to be 20 meters per second. Beautiful. All right, we're done. All right, so notice that this is going to be the slanted speed. All right, the velocity of the car when it lands on the ocean, the total time interval of the car is in motion, and the d is the... So, all right, let's answer for part B. So for part B, the velocity of the car when it lands on the ocean. So that's going to be the initial component speed. Well, we do know that the velocity, and that's going to be this velocity vector, is going to be Vx and Vy. And we do know that Vx and since this is going to be 37.0 degrees, we can use that as the reference angle to get the Vx. So that's going to be 20 meters per second, cosine of 37 degrees. Is it 37.5 or what does it say? Oh, it's just 37 degrees. Okay, beautiful. All right. So that means that Vx here is going to be 15.97 meters per second. And Vy is going to be, well, that's just going to be 9.8 times the time it takes for the thing to hit the ground at 30 meters. So I'm going to just solve it all the way. I'm just going to find the time it takes for the output to be 0. So the output is 0. The initial velocity is going to be 30 meters per second minus the initial component of the y direction. Remember, folks, that this is always constant in the x component. The y component is going to be vary, so that's going to be the initial velocity going downward at 20 times sine of 37 degrees, which is going to be 12.04 meters per second. times the time minus 4.9 t squared, because I'm already lazy enough to write the whole thing, so I'm just going to write that. So I'm going to have to use the what is that, the quadratic formula. So the time it takes for this object to hit the ground here is going to be 1.53 seconds. Forgive me, folks, if my teaching skills really do suck right now, because I am way too tired right now to even be doing this. So I'm going to take 20 sine of 37 degrees, and I am going to add that to 9.8 times that time it takes. I don't know if I store that. I think I did. Looks like I did. So the Vy here is going to be 27.07 meters, and the velocity, so the speed, so that was part A, the velocity of the car when it lands on the ocean. So the velocity of the car when it lands on the ocean is going to be 15.97 and 27.07 meters per second. So that's going to be 20. Let me double verify that. Cosine of 37 degrees. So I do trust my math here. So there we go. So that's part C. All right. So let's see what part C is. The total time interval for, okay, well, I just found that. So the total time interval for the car when the car is in motion, and the position when it lands. Okay, so the total time interval when the car is in motion, the time it takes for it to be, what was that? That's, oh my God, 50 times 2 divided by 4, square root the thing, is 5 seconds. So 5 plus t is going to be, these are just so random. 6.5453 seconds. All right, let's see. And now where the position is going to land. All right, so that's going to be pretty straightforward. So we found the time it takes for it to reach the ground at 30 meters. So let's find that time it takes to, so that's basically going to be 15.97 or 20 cosine of 37 degrees times that time. So x here is going to be 24 meters approximately. And what's it? The position of the car when it lands on the ocean relative to the base of the cliffs. So I'm gonna write the position here is going to be 24.51 meters and 30 meters. All right.